Hello again, this is Eric from RNItechnology in Toronto, Canada. This video will iterate some of the points, in short, what you covered in class during the training regarding planning and scheduling. In maintenance of equipment, and especially electrical equipment, it is extremely important to know exactly what's supposed to be done for each and every day, week, months, and year for several years, 5 or 10 years in advance. We have to know if we have to maintain a certain machine twice a year, 4 times a year, every month, every week. The equipment's supposed to be ready in time, and the proper schedule supposed to be in time and the right order, because otherwise it won't be ready. We waste assets, people time, and downtime of our production. Maintenance work supposed to cover people, place, time, tools and equipment, and the information of how exactly to do that. I've seen many cases where a maintenance job started just to realize that we have no idea how to disassemble a special coupling under oil pressure. How exactly do you do that? What is the right equipment that's supposed to be there, waiting for us when we do the maintenance, the disassembly? For each and every task that we plan in order to maintain it right and do a maintenance job, we're supposed to estimate how much time will it take. So the estimated time is a combination of the optimistic evaluation, of the pessimistic evaluation, and what is the most likely length of time it will take. So we add together the optimistic and the pessimistic, and 4 times the most likely. Altogether we have 6 components. 1, 4, and 5, 6. Divided by 6 will give us the average. And that's exactly what we are looking for. What is the average of estimated time for each and every job and maintenance task we're supposed to do? Based on that, we establish a critical path. Now, we know critical paths from the history, maintenance being done to that system. Now, the critical path is a path that cannot be delayed. If there is a delay in each and every one of those steps, or any one of those steps, it is not a critical path. A critical path is a path that we cannot change, cannot be delayed, cannot go beyond the estimation. The critical path is built of circles which are milestones. Those milestones are achievements that we achieved during the job. And the milestones can be a production stoppage, fuel flow stop into boilers, or material that being supplied, or any reasonable milestone during the job, something that we want to achieve. Between the milestones, we have a task. So between 0 and a full reserve tank of fuel ready for us for the generator, we have the fueling process. This is the task. So the first milestone is 0. We started there. That's the starting point. What is the end point? What is the milestone? A full tank. How do we go from 0 to 1? We refuel the tank. So this is the task that is being done between milestone, the beginning of the process, the end of the process. There might be several tasks being done in parallel. There is one here, there is one here. They are being done in parallel. So they are not conflicting. To achieve this task, we have 2 milestones in between. To do the parallel job, we have only 1 task to achieve. Each and every milestone and task will have its timing. When in time? When is it starting? How much time will the task take? It might be the optimistic, pessimistic, or the most likely estimation of time. We're supposed to put all that in a table, including what is known as a slack time. Time that we have in between the task that are not interfering with the process. Based on that, we will define what is the critical path. The critical path is the path that doesn't have any slack time. So we don't have to wait for another job to complete, and we can continue right after completion of the first task into the next task. This is a more complex description of a job. Many tasks are happening and taking place between the starting point and the end point. We can go from A to B to E to J to M, or we can go to D to L to M, or we can look at it as A, D, G, L, and M, or we can go that way or that way. The question is, which one is the shortest one? Which one doesn't have any slack time? That will be the most important path. That will be the path that we cannot modify and we cannot play with. That will be the critical path. So you can see numbers written on each and every task. So each and every task has the optimistic, the pessimistic, and the most likely time for its completion. For an example, the job or the task being done from milestone C to J will be, in the best case, 5 days. In the worst case, 25 days. But from historical reasons, we know that most likely it will take 10 days. Based on that, we will calculate the estimated time. 5 plus 25 plus 4 times 10, it's 30 plus 40, which is 70. We will divide 70 by 6. One for that, 4 for that. 70 divided by 6 is as much as it is, and it is the estimated time. And this is the table. For task from A to B, we have the best time, the worst time, the pessimistic, and the most likely. The estimated total time will be, for an example here, 2 plus 15 plus 4 times 7, the result divided by 6. In this case, we get 7.5. 7.5 hours. That is the estimated time for task from A to B. Going back to that system, with all the tasks, with all the milestones, now instead of 3 numbers, we have only 1 number. And that 1 number, like what we saw between A and B, is 7.5 hours. This is the estimated time. This is the best result. Will that result, with that time, will always take place? No. But when you come to plan and schedule a job, you're supposed to know that. You're supposed to know how much time will it take. Without knowing that, no planning and scheduling can take place. And now we are looking for the best time. So we take that diagram, here we see from A to B, 7.5 hours, and we put all of them in a table. What are the possible paths from beginning to completion? And there are many ways. 1, 2, 3, 4, 5, and so on and so forth. And we will choose the best one. It looks like this is the shortest one. From A to D to G, L, and completion M. When we know that, we know what are the tasks that we cannot touch. We cannot extend. This is the best performance. And that's what we have to keep in mind, like a hawk. All the rest will have some slack time. So those are not the critical paths. This is the critical path. In all likelihood, that is what we will see in the field. And the critical path is being calculated automatically by a lot of software packages, like Microsoft Project and other project and scheduling softwares. So we can do this by hand, or we can do this using one of the software packages, describing all the tasks, milestones, and assets and cost into the software. After you entered all the data in, all you have to do is click on critical paths. It will do it for you. When it comes to analysis of the job that you have ahead of you, you're supposed to have all that information. You're supposed to be the one who knows how to do the job. So most likely you did the job in the past. So you know what's supposed to take place on step A, on step B, on step C. You're supposed to come and say, hey, you said 7.5 hours? That is unreasonable. That's not realistic. So you are the expert. You will be the one who put your input into that system. And you will elbow your planning system into what it's supposed to be. The best and the most realistic way to do the job and to plan it. all the resources supposed to be there. To open a special coupling under oil pressure, you have to know in advance what type of a ratchet should you use. Without that, you cannot do the job. You have to prepare 3 people, one example. One to open with the ratchet, the other one to release in the same time, the 2 nozzles, and the third one to collect all the oil dripping from that coupling. So the planning part is supposed to be what to make, when to make it, how much to make, where to make it. Like the location is very important as well. Materials required, what we just described in my example, and resources required to do the job. When it comes to the scheduling, how best to make it? What is the right sequence? What comes after A? B, and then C, and then D. Very important. You are the expert. You will do the scheduling. Synchronization between departments and professionals. You know that you're supposed to disassemble a special oil pressured coupling. Is there an electrical connection there? Oh yeah, I forgot. Okay, so do we have to call the electrician to help us out? Yes. In order to do that, do we need an inspection when we later on reconnect it? Yes or no? Then we have to prioritize what comes first, what comes next, what is more important, what can be done in parallel. Monitoring of the execution. Is it being done? The fact that we know how and when doesn't mean that it was actually done. So that is part of what we're supposed to inspect. And someone's supposed to manage any challenge that comes to mind during the job. That process is an endless process. Scheduling, planning, doing the job, doing the documents, writing reports, doing the scheduling, doing the planning, and again, and again, and again, and again. It is an endless process that's supposed to be done as a circle. So it's supposed to include the scheduling, the planning, the actual execution and monitoring, and writing feedback, writing reports. You disconnected the oil pressure coupling, but you saw that something is missing. The ratchet is missing a special pin. Next time around, we need that pin ahead of time. Write it into the feedback, write it into the report. So when it comes to scheduling and planning, that pin will be there. And that summarizes the scheduling and planning video. Thank you and God bless.